Hey Ramblers, this video covers chapter 9.9 in our textbook and deals with sine, cosine, and tangent, which are the three basic ratios in trigonometry. Now trigonometry is an enormous topic, and it really started back with the Persians long after the Greeks and their math had kind of declined. The center of mathematics moved to Baghdad, and being very practical, they used math for navigation primarily, both across the sea and across the desert. So someone noticed that the ratios between the sides of a triangle were the same whether the triangle is very small on a map or very large, like on a desert. And they applied that principle to recognizing if I knew how far I moved on a map and at what angle, I could figure out how far I would need to move in the real world at the same angle. So all this really is based on similarity and on right triangles. So we're going to learn the three basic ratios, sine, cosine, and tangent, where they come from, and how to use them. I hope you like the video, and I hope you find that it helps. Thanks for watching. Okay, so mentioned in the intro, trigonometry is an enormous branch of math. And while it had its early roots in navigation, it is used today in finance, in the business world, in medicine, in all branches of science. As we look at phenomenon in nature, it is so prevalent that it really is an important part of the math you'll be learning in high school. But the easiest way to understand it and get introduced to it is through what's called right triangle trigonometry. So let's consider angle A. Now, angle A in triangle ABC is one of the two acute angles. The right triangle trig that we learn, the three ratios that I'll introduce you to in a minute, only apply to either angle A or the other acute angle, angle B. The right triangle trig that we're learning will not be applying to the right angle at C. Okay, so let's take a look at the measurements of the different sides. If I'm looking at angle A, then the side opposite angle A will refer to as the opposite side. The side that is right next to angle A will be the adjacent side. The other side next to angle A is the hypotenuse. But of course you recognize the difference between the hypotenuse and a leg. Hypotenuse is always opposite the right angle. So the three sides are all relative to angle A. If I was talking about angle B, then what I called the adjacent side to angle A would actually be the opposite side of angle B. And the opposite side of angle A would be the adjacent side of angle B. But no matter what, there's only one hypotenuse. Okay, so let's just keep our discussion in terms of angle A for the moment. Now, I decided to start off with 30 degrees because, well, that's an angle we're getting comfortable with as we learn special right triangles, and it's one that you definitely know the ratio of the opposite side to the hypotenuse. Now you'll recall that in our study of 30, 60, 90 triangles, the opposite side was A and the hypotenuse was 2A. So we would expect the ratio of the opposite side to the hypotenuse to be 1 over 2, or 0.5, and that's exactly what it is. No matter how much I move the size of the triangle, as long as angle A remains at 30, the ratio of the opposite side to the hypotenuse is 0.5. It doesn't matter that the hypotenuse is changing size and the opposite side are changing size. The fact that they are maintaining a 30-degree angle requires that they are moving proportionally, and so their ratio remains at 0.5. That ratio of the opposite side to the hypotenuse is so important that we call it a specific name, and that name is sine. Now we abbreviate it SIN, but no one calls it sin. And it wouldn't really mean anything if you don't relate what angle you're talking about. So we would say the sine of angle A equals 0.5. Now, you'll recognize that as I change the measure of angle A, so now it's only 10 degrees, the ratio of the opposite side to the hypotenuse changed, and since the sine is that ratio, it has also changed. So recognize that as the angle measure changes, the sine of the angle changes. But if the angle stays the same, no matter how big the triangle, whether it's a little triangle on a map or a big triangle out on the desert or in the ocean, the sine of the angle stays the same. Okay, let's take a look at another of the ratios. Another one is the ratio of the adjacent side to the hypotenuse. And in this case, that's equal to 0.9. Now if I get back to a 30-degree angle, you'll see that that ratio is 0.87. And so long as I maintain a 30-degree angle, the ratio stays at 0.87 because the adjacent side and the hypotenuse side will maintain that relative size to one another if the angle stays the same. So that proportion was so important, or that I should say that ratio was so important that we gave it a name, and that was cosine of angle A. Again, cosine is the name. You'll recognize that it's kind of like sine, but it's cosine. And no matter how big the triangle is, the ratio of those sides adjacent to a 30-degree angle and the hypotenuse of a 30-degree angle will always be in the same ratio. Okay, the last of the three ratios I want to look at is called tangent. And once again, as we move the size of the triangle, the tangent doesn't change. But if I change the measure of the angle at A, then the tangent does change, because tangent, like sine and cosine, is dependent on the size of the angle, not the size of the triangle. Okay, those three ratios are so important that, like I said, they have a name, and we've given them a special mnemonic for remembering what they are. I'm sure you've seen this mnemonic. It's SOHCAHTOA. So there you have it. SOHCAHTOA. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent equals opposite over adjacent. We'll take a quick look at how to use some of these ratios to solve problems, and then we'll conclude the video. Suppose you were given a right triangle, and you knew that one of the angles was 28 degrees, and the hypotenuse was 12. And say you wanted to solve for the side opposite the 28 degrees. How would you use trigonometry to do it? Well, you'd set up a ratio. You would first think about which ratio involves the side opposite and the hypotenuse. And hopefully from the last video you recognize that that is sine. So the sine of 28 degrees is going to equal x over 12. Now, we don't expect you to know the sine of 28 degrees. So you would check your calculator or page 422 in our textbook, and you would see that the ratio of the sides opposite a 28-degree angle and the hypotenuse is 0.4695. And it doesn't matter whether that triangle is gigantic, like on the ocean or in the desert, or really small, like on my iPad. The ratio of the opposite side to the hypotenuse will always be x to 12. So now, in order to solve for x, it's really just as simple as solving this simple algebraic equation. I'm going to multiply 12 times 0.4695, and that will be my answer for x. So x equals 5.634. As you can see, we can use this whenever we only have an angle and one side, because from here I could use the Pythagorean theorem to solve for the adjacent side, y, or I could use another ratio involving an angle, the hypotenuse, and the side right next to it. That, of course, would be cosine. I know that the cosine of an angle is equal to the adjacent side over the hypotenuse. So the cosine of 28 degrees equals y over 12. So I go to my calculator and I look up the cosine of 28 degrees, or on page 424 in our textbook, and I see that cosine of 28 equals 0.8829. Solving for y, I get 10.59. So as you can see, to solve a right triangle with trigonometry, you need an angle, a side, and then your trig table or your calculator. Okay, Ramblers, I hope this helps. Thanks for watching.